Okay, welcome back to Cells and Diffusion Part 1. We're still on this booklet, and this is going to be Lesson 5, which is a follow-up lesson on the skeletal system. That's why there's number 2 next to it. And with the beginning of every lesson, you're going to start off with the do now, which is the first 8 questions over here. Okay, so if you want to pause the video really quick, and then we'll go over it together. All right, so as we go along, I'm going to try my best to make sure I bring up as much as the previous lessons as possible. That way you know where I'm getting this information from, and it's not new information. All right. That way you can go back to previous lessons if you need to revise certain parts of it, some parts that you maybe didn't get the first time. Okay. So number 1, suggest one function of the skeleton. If you saw my last video, you'll remember that I made up this silly little sentence. Okay, and that sentence was skeletons, okay, because we're talking about skeletons, make spicy pulled pork. Okay, and the reason why we made up this sentence is because each one of those letters, okay, make spicy pulled pork, right, represents a different function of the skeleton. So if we go through this, you have movement, okay, it stands for the M, the S stands for support, support. One of the P's stands for protection, and the other one stands for production. And we know that production actually refers to the production of blood cells, okay, red and white blood cells. So number 1 and number 2 actually are asking 2 functions, all right, so a total of 2 functions of the skeleton. So choose whichever 2 that you wrote down. And if you didn't get either one of these, I would suggest writing down all 4 of them so that you're constantly reminding yourself and you can see for yourself which ones stick better than others. Okay, just so that you remember, okay, you don't have to use this sentence at all. You don't have to use skeletons make spicy pulled pork. You can use whatever sentence that you want as long as it fits the criteria. It has to have the letters, right? It has to have M, S, and 2 P's. Okay, moving along. Number 3, state the names of the bones in the leg. So this is going to be kind of a reoccurring question here where it asks the bones in the arm, bones in the leg, and so it's asking for 3 specific bones, right, that are in your leg, not joints. Okay, be careful that you're not using your knee as a bone because your knee is more of a joint. Okay, so the bones are going to be your femur, which is above the knee, right? That's the longest bone in your body. Your tibia and the fibula. Okay, and please make sure that you have the spelling correct for these, just because you don't want to, write something that your teacher does not recognize, right? And unfortunately get a question wrong. So remember that the tibia is the larger bone that's in the front, that's kind of like your shin bone, all right, and the fibula is towards the back, all right, and slightly to the side. Number 4, suggest the name of an organ in the skull. All right, so the biggest organ that we've been talking about that's in your skull is your brain. Okay, that one's straightforward. Number 5, state the name of the soft tissue in the middle of the bone. So if you remember from last lesson, lesson 4, okay, your bone structure is made out of 3 parts. You have your outer layer, your inner layer, and the soft tissue that's right in the middle of the bone. Okay, so your outer layer is that hard stuff, okay, that's made out of calcium and manganese, or it's strengthened by it. You have your inner layer, which is that spongy tissue, okay, and then you have the middle of the bone, which is made of a soft tissue called bone marrow. Right, this is where that blood cells are produced. Number 6, state the name of the type of joint found in the elbow. So remember that your elbow, right, it goes only in one direction, okay, or bidirectional, I should say. It goes up and down, okay, or to and fro, and this one should remind you of a door, and a door has hinges, which is why it's called a hinge joint. Number 7, state the name of the joint found in the skull. Now you know that your skull, the skull itself doesn't actually move, it's more your neck, right? Because you might be thinking, well, my skull moves from side to side or it can turn. That's actually your neck, right? That's your pivot joint. So this one is going to be called your fixed joint, right? Because it doesn't move. Lastly, number 8, state the name of the minerals that hardens bone. So we actually just talked about this a couple seconds ago, and those 2 minerals, right, are going to be calcium and manganese. Okay? So there's your 8 questions, all right, or 8 answers, I should say. Please make sure that you have the correct answers on there so that you can make sure that you don't revise the wrong ones, all right? Okay, so a majority of this lesson is actually going to be a kind of a follow-up on the last lesson. So if you did not get lesson 4, all right, I would strongly recommend that you watch that first before you do this. But that being said, there's still lots of parts in here that will help you understand lesson 4 even better. So just make sure that you go in order and you focus on the parts that you don't understand. Okay, so the first section here is called the function of muscles. So we're going to be focusing on movement a lot. And let's just start off in line 2, where it reads, the function of muscles is to pull on bones at skeletal joints to make the bones move. Okay, so this, I did mention this in the last lesson where the muscles are actually pulling on the bones. There's no pushing actually, all right? Just pulling. When muscles pull on the bone, we say that the muscles contract, okay? So what I want you to do is I want you to highlight this section here because we're going to be focusing a lot on this, and this is the main reason why muscles work. So this word contract right here, okay, I'm going to be using this word a lot because it's how we describe the muscle movements. And when something contracts, we say that the muscles actually get smaller, right? So contract also means to condense. It means to get smaller in a general sense. And when your muscles are actually attached to a bone and something gets shorter, right, the inevitable effect, what's going to happen is that bone is going to be pulled on by the muscle, okay? Now, the opposite is also true. So when a muscle doesn't pull on a bone, then we say that they relax, okay? So these two words here, these two words right here, contract and relax, I want you to, underline it if you're using a paperback copy. If you're using a digital, just, you can follow along with what I'm doing right now, make it bold. And the reason why I have you bold, contract and relax, is because I'm going to be using these two words quite a bit. And like I said, it's kind of the main way that we describe muscle movement. So you need to be sure that you recognize these words and what they mean. And that being said, when we say that they relax, okay, in muscle terms, we say that the relaxation is when the muscles kind of get longer, right? So they don't shrink as much, okay, and quite the opposite, they actually get larger, okay, they stretch out almost. All right, moving along. Muscles need energy to contract, right? Because no life process is actually free. There has to be some sort of cost to it. So muscles need energy to contract. So the life process of respiration is needed, all right? So please underline respiration because you need to know what respiration is, okay? This life process is carried out in the mitochondria, all right? So this one, again, also very important, because there's two phrases that I want you to memorize for respiration mitochondria. And the first one is that respiration is when you use energy from the food that you eat, okay? So when you have a steak or breakfast or whatever, what kind of food it is, there's going to be energy stored in there, okay? Chemical energy. And your body has to absorb that energy in order to use it. And once you have it, okay, the energy combined with the oxygen that you breathe in you're able to basically release that energy and utilize it, okay? And this whole process is carried out in the mitochondria. And the other phrase that I want you to memorize, okay, or know, is the mitochondria is the powerhouse of the cell, okay? Powerhouse meaning it produces energy. Okay, so moving along. This is where we kind of get some of the more vocabulary terms, so please make sure that you're following along. Muscles are attached to bone by tendons. Okay, so there's your first word. Muscles are attached to bone by tendons. Now, it's important to know that tendons are not stretchy. Okay, the best analogy that I can think of is if you have a rubber band that's attached to a stick. Okay, if you pull on the rubber band for a little while there, right, if you're not pulling too hard, you'll notice that even though you're pulling on the rubber band, the stick doesn't actually move, okay? And that's just because maybe the stick is too heavy or the rubber band's not strong enough, and if you pull hard enough, maybe the stick might move, but the rubber band might actually break, depending on how strong it is, okay? And the same thing happens to your muscles. They can only stretch a while, and after a bit, you're actually gonna pull certain muscles, which is not good. So tendons themselves are not stretchy; they're more like string. Okay, and strings, if you pull on them, they become taut, right? And if you pull on it even more, it's going to pull whatever it's attached to. So in this case, your tendons are attached to bones, okay? And when you pull on tendons, it's going to just pull the bone, okay? All right, so your other one is going to be ligaments. All right, now ligaments attach bones to other bones, okay? And so they need to be a little bit more stretchy because your bones, they should be able to move around with a little bit of freedom, okay? Because your bones still have to move in some direction. And so when ligaments and tendons work together, okay, this is how your body does a full range of motion. Okay. Now there's a video on YouTube that you can look up that helps you memorize, what do tendons do, what do ligaments do, and the best one that I found is knowing that, if I ask you on an assessment, tendons attach what to what. You might be confused. Is it bone to bone or muscle to bone? And so if you're thinking about tendons, okay, I want you to think about the word bottom. Okay, B-O-T-T-O-M, bottom. And the reason for that is because bottom has the letters B, T, and M. Okay, and I want you to memorize it like bone, tendon, muscle. Okay, bone, tendon, muscle. All right, so tendons, bottom, bone, tendon, muscle. Ligaments, all right, you're going to memorize the word blob, B-L-O-B. And the reason for that is you have bone, ligament, bone. Okay? B-L-B. Bone, ligament, bone. So those two words, bottom and blob, are going to help you memorize that tendons attach bone to muscle and ligaments attach bone to bone. Okay? Alright, so the last one here is going to be cartilage. Okay, and I'm just going to highlight this last sentence, or last two sentences, because it's all kind of together. So I mentioned about cartilage in the last lesson because cartilage you can find in your ear. So if you touch your ear, you notice that it's a little bit hard, okay, but it has a shape. If I was to cut open my leg right now, okay, at my knee joint, I would notice, okay, that there's actually cartilage at the end of my bone. So at the end of my femur, okay, at the end of my femur and at the ends of my tibia and fibula, where the three of them meet at that joint, there's going to be cartilage. And the reason why there's cartilage is because it acts as a shock absorber for one, but it also reduces friction. Okay, and there's actually a lot of parts in the knee, such as synovial fluid. Okay, there's actually like a fluid inside your knees that help reduce the friction as well. But the cartilage does that as well. And the cartilage and the synovial fluid will help reduce that friction every time you bend your knees. Okay. The shock absorber part of it comes when maybe you jump up and down, and when you land on your feet, okay, your bones will actually slightly hit each other. Okay, so the femur will actually hit on the tibia and the fibula. And the reason why it doesn't hurt so much is because you have cartilage there to kind of absorb a lot of that force, okay, coming down. And it's not just your knees as well. All the bones, okay, all your bones have cartilage in between them, so that when you're hit or when you jump or run or doing all these physical activities, it doesn't hurt as much because you have all this cartilage to help absorb a lot of that impact force, whatever you're doing. Okay, so cartilage is actually really, really important, because if you didn't have it, then you'd actually feel your bones almost grinding on each other, all right, and it creates a lot of joint discomfort, okay, and a lot of pain. All right, so now that we got that out of the way, we can kind of move down and talk about antagonistic muscles. So another term that you need to know for movement. All right. As muscles can only pull, so I'm starting on line 5 here. As muscles can only pull, not push the bones to make them move, They usually work in pairs called antagonistic pairs. Okay? Now, antagonistic pairs, the first thing that you need to know, all right, is that it's a pair. Okay? There's always two involved. There's always two muscles involved, and they always work together. Okay? They work in opposite directions to move bones in opposite directions. So we're going to look at the arm as an example right here. Okay? The biceps and triceps, okay, are two muscles in your upper arm. Okay? So your biceps, if you have your hand out and you have your arm stretched out, okay, the bicep is the one that's facing the sky. Okay? And your triceps are kind of below that. All right? The biceps and triceps are muscles that control the movement of your lower arm, and they work in opposite directions. When the bicep contracts, all right, the triceps relax. So there's your two words, contract and relax. So contract means to get smaller, okay, or to shorten in length. And when the biceps contract, the lower arm moves upwards toward the shoulder, and that's because your biceps, okay, your biceps are connected to your forearm. All right, and remember what we said about when muscles contract, they pull on bones. So your biceps are actually pulling on your forearm. Okay, so that's when your biceps contract. When your biceps are contracting, all right, at the same time your triceps are going to be relaxing. That means they stretch out a bit more. Okay, and when the biceps relax, so the opposite, when the bicep relax, the tricep then contracts. Okay, and that means your lower arm is going to be moving down away from your shoulder. Okay, so that simple movement of, raising your lower arm towards your shoulder and lowering it away from your shoulder, okay, those two movements involve two muscles. All right, and you actually have the same antagonistic pairs in your legs as well. So your hamstrings and quadriceps are in your upper leg. Okay, so between the knee and your hip. All right, that's where your hamstrings and your quadriceps, kind of the same thing. Your quadriceps are going to be in the front, while your hamstrings are in the back. And this allows you to move your lower leg, okay? So your tibia and your fibula, okay? So that's your antagonistic pairs, and hopefully this animation kind of helps you understand how it works when you're moving your arm up and down, up and down. And if you're still confused, there's a lot of videos on YouTube that will help you understand antagonistic pairs. But this concept here is actually quite advanced. All right, so as long as you understand that antagonistic pairs are pairs of muscles, right? Two muscles that work together, and they both do opposite things, right? So one muscle will always contract, and if one is contracting, then the other is always relaxing, okay? And vice versa. And each motion, right? When one muscle contracts, it means one motion, right? But if that same muscle relaxes, then it's the opposite motion. It goes in the opposite direction. Okay. Moving down, we're going to be moving on to a new kind of study here, and that study is called biomechanics. Okay. And you might be a little bit scared when I say that there's a little bit of maths involved in this. But you don't need to be worried because it's actually quite simple. Okay, so the biomechanics is the study of forces acting on the body, and the human body is actually a remarkable thing because there's lots of things that we understand about it from a physical point of view, and to understand all of this, you need to understand certain physics of how the body works. So there are some words that you need to know. So the first word that you need to start, this should be highlighted, okay, not in red. And the first word that you're going to need to know is pivot. Okay, pivot. And you've heard this word before if you saw the previous lesson, and that pivot is because the pivot joint, right, which you can find in your neck, is a point around where something rotates. So for instance, your neck, right, your pivot point will be right at the base where your neck connects with your skull. And that's a pivot because you can move your skull around, right? You can turn your head left to right without your neck moving. Okay, so the pivot usually never moves. Okay, the pivot doesn't move. And here you have a force, right? Some sort of force, and in this case it looks like gravity, and a moment. Okay, so if you scroll down, you'll notice that when a force acts on something, okay, that has a pivot, it creates a turning effect. And a turning effect is actually known as a moment. Okay, and in your body you have like pivots and levers and all these moments that are involved when you're moving around. And in physics, we came up with an equation that helped us out. Okay, and that equation is moment equals force times perpendicular distance. Okay, now the perpendicular distance is actually quite important because you can't just take a distance on whatever you're measuring, right? It has to be perpendicular. And perpendicular means that it's at a distance at a right angle, right? 90 degrees from the pivot to the line of the force. So what these letters represent on the bottom here are actually the units, okay? So just like how if you measure distance, all right, this m actually should be a lowercase m, so can you just cross that out and put a lowercase m, okay? And this m stands for meters, right? Because if you measure distance, there's also different ways that you can measure distance, but in science, we have what's called standard units. And the standard units just helps everything be in one form instead of having, well, this is in kilometers, this is in centimeters, this is in millimeters, right? We all want everything in one standard unit. So the unit that we're going to use is meters, okay, for distance. For force, okay, for force we use the letter, the capital N, and that capital N stands for newtons, which is named after that famous scientist Isaac Newton, right? Because he's the one that's kind of discovered all this. And force, right, is measured in newtons. And when you multiply these together, all right, you get the moment, and moment is measured in Newton meters, all right, Newton meters. And so when you're given a problem, right, you should be given numbers, right? So if I said, with a force of 5 newtons, okay, 5 newtons, and a perpendicular distance of 3 meters, right? So you have 5 newtons and 3 meters. And what you would do is you just multiply them together. So 5 times 3 is 15, okay? And you have 15 Newton meters as the moment, okay? So you say the moment is 15 Newton meters, not just 15, right? In science, it's actually very, very important that you include the units, because if you don't, then we're not sure what you're talking about. 15 what? 15 oranges, 15 apples, right? 15 Newton meters, okay? All right, so here's a problem here, okay? So you have the arm, okay, and it shows you where the pivot point is. So the pivot is going to be right at your elbow, okay, and you have a force going downwards. You have a weight, okay. So the force going downwards is 12 newtons, all right, and you have your pivot, which is your elbow, and an upward force, which is actually coming up from your forearm, okay. So the weight is 12 newtons, and it is 0.3 meters away from the pivot. And just like before, we can work out the moment by using the equation moment equals force times perpendicular distance. And in this example here, okay, one of the greatest things about these questions is it gives you part of the answer, actually, because it tells you, right, these are clues. These units are actually clues as to which one it is. So if it's in newtons, all right, that's a clue that that's a force, right? Because going up here, we know that force has to be measured in newtons. It can't be distance, because distance is measured in meters, okay? So this 12n, even if you didn't know, you should think, oh, well, 12n, n stands for newtons, and newtons is force, okay? So you're replacing the force with newtons, so that's 12, and the distance, okay, is the other number, 0.3 meters. Okay, 0.3 meters. So 12 times 0.3 comes out to 3.6. Okay, 3.6 what? 3.6 Newton meters. So below that says, however, the muscle also applies a force to the arm to counteract the movement of the weight and keep the arm still. So notice how the arm, I know it's a picture, but it's not moving. There's no signal to show that the arm is moving downwards, okay? The arm is standing still because this person is applying the same force going upwards, right here, the same force going upwards to counteract. Okay, so this person has the same amount of force going upwards as there is going downwards. And when there's two forces going in opposite directions, okay, they cancel each other out, which means that there's no movement at all. So imagine you and your friend are pushing a box, and you're pushing the box in opposite directions. Okay, you're pushing it one way, and your friend is on the opposite side of that box, pushing it the other way. And you know, depending on who's stronger, right? If you're stronger than your friend, then you're going to be the one to push that box, right, in his direction. But let's just say you and your friend have the equal amount of strength. Okay, you're both pushing the force at the same force. Is the box going to move? Okay, and the answer is no, because when you have the same force going in opposite directions, they cancel out, and so then we call it the net movement, right? Net movement is zero. Okay, doesn't move anywhere. So if the moment of the muscles is bigger than the moment of the weight, then the arm will lift up. Okay, so if this force going up is bigger, right, than this, then the weight will go up. And the opposite, vice versa means opposite. Okay, if the weight, right, was bigger than this force right here going up, okay, then the weight would go down. So for the arm to stay still in this position, the moment must be equal in size. So this force going down and this force going up has to be equal. Okay, so here's a question that we're going to try out together. Okay, so question 1, is the arm going to move up, down, or stay in the same position? By looking at this diagram, is it going to stay the same? So pause the video right now. Okay, try out questions 1, 2, and 3. Okay, I just wanted to zoom in on this picture because I noticed that you might not have a clear picture of this, so I wanted to zoom in as much as possible so you can see clearly what I'm trying to explain here. Okay, so let's go with question 1. Is the arm going to move up, down, or stay in the same position? So the answer to this one is going to be the arm is going to stay in the same position. Okay, it's going to stay the same. It's not going to go up or down, right? And so that's the answer to question 1. It's going to stay the same. Question 2 is the important bit that you need to understand, is explain your answer to question 1. Now, the reason why it stays in the same position is because the upwards force, okay, the upward force by the muscle is the same as the downwards force, okay? And actually, sorry, I apologize. So the upwards moment, okay, and the downwards moment is the same. And as we saw right here, okay, for the arm to stay still in this position, the moments must be equal in size but in opposite directions. So does that fill the criteria right here? Upwards moment is the same as the downwards moment, okay? And you'll notice that they're going in separate directions, okay? And that's the reason why this arm is not going to move, okay? It's because both moments going in opposite directions are equal to each other. All right, number 3 is a little bit of the maths portion that I mentioned about. Calculate the force applied by the muscle. Now, the difficult part here is that you have to rearrange the question. And the best way to explain this is when you're rearranging equations, you need to make sure that whatever you're solving for is on one side of the equal sign. So right now, the question is asking for the force. And if you want to figure out the force, okay, then your equation, okay, will turn out to be force equals, okay, force equals moment time, or sorry, force equals moment divided by distance. Okay, force equals moment divided by distance. And if you look at the question, right, if you look at the diagram, those two, moment and distance, are actually given to you, right? And so that's a clue that you can use when you're going into assessments, right? Or if you're trying to solve this out, is whatever you're being asked for, put it on one side of the equal sign, and everything on the other side of it, check if you have those values. Okay, so for force, right, we're going to need moment and distance. And if you look at the diagram, do you have moment? Okay, and the answer is yes, you have your moment right here, 3.6 Newton meters. Okay, good. Check that off, you have your moment. And then do you have your distance? Okay, and you can see right here, yes, you do have a distance. Okay, and so now that you have both of the values, what you're going to do is you're going to put it together. Okay, so what we do in these sorts of questions is we just basically replace what you have. Okay, so you have 3.6, okay, which is going to be divided by 0.05. Okay, divided by 0.05. And when you get those values, okay, when you get those values, what you're going to get, sorry here, so 3.6 divided by 0.5, or 0.05 meters. And the answer that you should get is 72. If you punch that into your calculator, you're going to get 72. Now, just be careful here because you're not finished. All right, it has to be 72 with the type of units, and you're asking for force. And if you remember from the top of the page, force is always measured in newtons. Okay, so you're going to put a capital N at the very end there. All right, capital N. Perfect, and that's how you solve these questions. Okay, now there is a different method of figuring out the equation for this, and if you want to look up the triangle method for formulas, okay, stick around at the end of the lesson and I'll show you how to do that. Okay, so now that we finished this, all right, we're going to move down to the knowledge check questions. All right, so that's the end of the lesson as far as content wise, and so now what I want you to do is pause the video and try out these knowledge check questions at the very end of this lesson, and we'll go over it together. Alright, so let's go through these questions really quick. Number 1, suggest a term used to describe when a muscle is pulling on a bone. Alright, so this is why I say it's quite important. So this term right here is going to say contract, right? When you're contracting, you're pulling on something. And the opposite of that is question 2. Suggest a term used to describe when a muscle is not pulling on a bone. And this one is going to be relax. Okay, so remember, contract and relax are both going to be opposite terms that you're going to use to describe when muscles are pulling or not pulling. Number 3, state the names of the muscles in your upper arm. So above, between your shoulder and your elbow, right, between your shoulder and your elbow, you have two muscles, two big muscles actually, and those muscles are going to be your biceps and triceps. Okay, and it's actually quite important to know what the name of these muscles are because it helps you understand what part of your body is moving. Number 4, suggest what we call these pairs of muscles. So remember, pairs, okay, and the term that we're going to use is antagonistic. Sorry, I spelled that wrong. Antagonistic muscles. Now remember, antagonistic muscles always work in pairs, okay? There's always two of them. State the function of tendons. Okay, so here we go. So those two words that I asked you to remember, blob and bottom. Okay, blob and bottom. So this one, tendons, right? T has bottom. Okay, and that means that you have bone, right? Tendon, muscle. Right? So in this sense, tendons are attach or connect bone to muscle. Okay, so you got one figured out, which means that the other one should be fairly simple, right? And that word is blob, right? B-L-O-B. And this one is bone, ligament, bone. Okay, and that means that ligaments attach or connect bone to bone. Okay, so that should help you memorize what tendon and ligaments both are. Okay. Number 7, suggest how the muscles in the upper arm enable movement backwards and forwards in the lower arm. Okay, so this one is worth 4 points, which means that it's going to be a little bit more of an explanation. You're going to have to say a bit more than just a couple words. Right? So, and using the terms, using the correct vocabulary will help you get those points as well. So in your upper arm, you have your biceps and triceps, right? And the first part that happens is your biceps, okay, contract, which biceps contract, and triceps relax, which make your lower arm move towards, towards your shoulder. And then you can explain the opposite, right? When biceps relax and triceps contract, right, your lower arm moves away from the shoulder. Okay. So this is what I mean by it helps to memorize some of the muscles, right? And it should help you understand, right? When your biceps contract, right? It should feel like you're pulling, okay, on your forearm. Okay, you're pulling on your forearm, and then the opposite should be true. So your biceps are relaxing, which means that they're getting longer, and which means that your triceps on the opposite side of your biceps are actually getting shorter. They're contracting. Okay, perfect. Number 8. State the word equation for calculating a moment. So you're asking, right? The question is asking for a moment. So your moment should be on one side of the equal sign. And the rest of it is going to be force times perpendicular distance. Okay? You don't need to put the units, right? Because it's just asking for a word equation. All right, number 9, define the term moment. Okay? Define the term moment. And this one, you could put a turning effect, but that doesn't really describe everything. So what we're going to put is when a force acts on something that has a pivot. Okay, so when you're answering questions like this, all right, this is the reason why you need to revise the vocabulary in every lesson. Okay, because when you don't have the vocabulary, it's hard for teachers to, think that you actually understand the content, okay? And when you use vocabulary, it actually helps you write less, if you get what I'm saying, okay? Okay, and the last one here is going to be number 10, which is calculate the force if the moment is 3.6 Newton meters and the perpendicular distance is 0.3 meters. Now notice how this one's worth 4 points as well, because for questions like these on an assessment, all right, little details matter, okay? So where you're going to get your first points is actually writing down the formula, okay? So in this sense, it's going to be writing down the equation. So you're asking for force, okay? So same thing, you're going to start off, You're going to start out by writing out what you're looking for, force, okay? And that's going to be on one side of the equal sign. And the rest is figuring out, well, is it moment and distance multiplied or is it divided? If it's divided, which one's on top? Okay. And in this one, it's going to be moment divided by distance. Okay. Divided by distance. So if we replace the words with the numbers, right? So in this one, the moment is 3.6 Newton meters. Okay, Newton meters. And you divide that by 0.3 meters. Okay. And if you put that in a calculator, you're going to come up with 12, right? Now, the tricky thing is that your calculator doesn't know what you're solving for. It just knows the numbers, right? And so if you finish your question like this, okay, you're not going to get full marks. Okay, and the reason is because you don't have the units, and the units for force, as we know, is in newtons, and that's capital N. Okay, so this is where most of your points will come from. You get 1 point for the formula. You get 1 point for putting in the numbers, right? You get the third point for the actual answer, which is 12, and the fourth point for the actual units. Okay, so this is why I say little details like this actually matter. Things like units. I've had many students who did not get full marks just because they didn't get that last bit in there, the units. Okay, even though their process was completely perfect, you miss that 1 point. Okay, and that's it for everything. All right. So like I said, if you want to check out the triangle method really quick, stick around and I'll show you what that is. Okay, so this is for you guys who need to know what the triangle method is. And if you want to draw a triangle like this onto your page, on the student's note page, that's completely fine. What these letters represent, so this is going to be your moment. This is going to be your distance. and this is going to be your force. Okay, so these three right here are how you're going to figure out which formula you're going to use. Now, the first one that the booklet gives you is quite simple, okay? Moment equals force times distance. And you know this distance is supposed to be perpendicular distance, so that's good. And the way that we figure this out is the triangle method works by covering up what you're looking for. So if the question is asking you, look for the moment, right, in this problem, then what you would do is you would cover up moment, okay, and you're left with force and distance. And they're right next to each other, so this one is actually multiplied, okay, force times distance. Now, imagine that a question asks you, figure out the force, right? And we've done this before. So same thing, you would start off by force on one side of the equal sign, okay? Cover up force, okay? And you're left with moment and distance. Now notice how moment is on top of distance, okay? So what you're going to have is a division sign, and you're going to have moment divided by distance. Okay, so you get force equals moment divided by distance. And the last one that you can get from this is distance, right? So same thing, you're going to cover up the distance on the triangle and you're left with moment and force. Okay, so same thing, you're going to divide moment by force. And whatever question it gives you, okay, it should be giving you the values for moment, all right, and the values for distance if you're calculating for force. And same thing for distance. If you're calculating for distance, then it should give you the values for moment and for force. And that's how you use the triangle method.